Good evening. My name is Caleb Jones, and tonight I will be speaking to you about weapon detection with computer vision. First, I do have a quick disclaimer. This presentation features footage of a gun, and I wanted to mention it now before we get started so that nobody is caught off guard. And I'll mention it again right before we get there. Mass shootings. These are gun-related incidents in which 4 or more people are injured or killed by a firearm. These have occurred a wide variety of places, but the ones we tend to hear most about are the big public places like schools, concerts, restaurants, shopping centers, and places of worship. And many different kinds of weapons have also been seen in these incidences, but the ones that are the most common are pistols, and 9mm and 22 calibers top this list. And how can we prevent these? Usually we hear about calls for more legislation or tighter restrictions on abilities to obtain firearms. But what I wanted to know is, what can technology do for us? And that led me to computer vision. So computer vision is generally broken into a few main tasks. We have image classification, which assigns a class label to an image. Object localization involves drawing a bounding box around one or more objects in an image. And object detection combines these two tasks by drawing a bounding box around each object of interest in an image and giving it a class label. There are many popular frameworks out there for doing this kind of task right now, but in the realm of object detection, I decided to go with the YOLO framework built by Darknet. And YOLO stands for You Only Look Once, which is a reference to how the model processes an image. And I chose this model due to its speed in training as well as deployment. So I built a transfer learning model on the YOLO V5 framework. And my data set was almost 700 images of handguns in various settings and orientations. And this was supplied by the Andalusian Research Institute at the University of Granada. And they also did the legwork for me to draw bounding boxes around the training images so that the data was just ready to go straight to training. I also ran several versions of my model, but the one that performed the best in my testing was the one I'll show you tonight, and that one had no resizing or augmentations applied to the images prior to training. And my training was 1,500 epochs, and I did this on the Google Cloud Computing platform, which they call Collaboratory, and I use their GPU services. So now I'm going to get to the demonstration, and this is going to be a pre-recorded video of myself. I will be handling several different household objects, testing whether or not the model sees that as a pistol. When the model thinks it sees something that's a pistol, it will draw a blue bounding box around it and assign it a confidence rating. And just heads up, here we're going to be seeing the gun. So first off, I have this pasta spoon, and you can kind of see the blue box flickering on and off. The confidence is low, but it's thinking that it sees a pistol a few times there. Next up, I have this grilling spatula, and for the most part, it's not seeing a pistol, but a few orientations it does. The next one is a pair of wire strippers, and my model did have a hard time with these. It thought that that was a pistol, although the confidence jumped around between 40 and 80%. And then I have this hammer, and that was pretty good as well. So now here comes the gun, and first off, I'm going to show that it's empty. And you can see even before the weapon is fully assembled, the model is picking that up as a pistol, and the confidence is above 90%. So also display a few different angles and orientations as well. This is a little uncomfortable pointing the pistol at the camera, but I just wanted to demonstrate the model's abilities. And even facing the other way with my hand in front of the gun, it still sees it as a pistol with very high confidence. So this is exactly what I hope to see with this model and applications. Security cameras are already everywhere, although their current use is intended to limit loss to businesses in the event of theft or accidents. By leveraging the advances in computer vision, current security systems could be turned from passive into active systems and utilized and deployed as part of an early warning system in high traffic public places like those mentioned earlier. And that could help prevent or limit the impact of the next attempted mass shooting. Specifics of use would need to include defining a minimum threshold or confidence, as well as defining a minimum time limit before triggering an alarm. And this would help avoid any boy who cried wolf type scenarios. And I would like to continue developing this model as well. Next steps include training the model on more classes of weapons frequently used in shootings, like rifle type weapons, as well as knives. And then eventually I would like to deploy this to a real security system for live testing with real weapons in a closed environment, and eventually rolled out to the public. I think the public could really benefit from this technology. That's all I have for you tonight. Thank you for being here. I welcome any questions you have, and if you'd like to get hold of me, I'm available here.